Okay, this section is very easy, okay? There's not a lot of work to do, okay? But there are two concepts that you do have to pretty much memorize. And it deals with special right triangles, specifically triangles that are isosceles. So a right isosceles triangle has degree measures of 45, 45, and 90. And the other one is what we call a 30, 60, 90. It's named by the angles it has. They have specific ratios of sides. We're going to learn about those in a second. This stems from trigonometry, which will be our next lecture. Okay, we'll do a couple of days of that, and I'll explain that more as we come, because all right triangles can simplify to the same right triangle measurements, which are the basis for trigonometry. Okay, what we're looking at is all right triangles that have 21 degrees and 69 degrees on it will simplify to the same. They're all going to be similar. It goes back to last chapter. Okay, that's what the basis of trigonometry is. People freak out when they hear about trigonometry. It's not that tough. Okay, just lose the freak and you're going to be fine. Okay, so today, 30 60s and 45 45s. You have to know these. These are very important, not just for the rest of this semester, but you're going to deal with them in Algebra 2, trigonometry, and calculus. You got to believe me here, okay? Okay. Now, Section 3, special right triangles, your resources. The notes, okay? Chapter 8, Section 3, the PowerPoint, okay? Good one to go through. The notes, Chapter 8, pages 6 and 7, okay? Just list it again up there. And finally, I added a worksheet. It's called Special Right Triangles. Okay? Probably not a bad idea to take a few of those and check your knowledge, because what I've done is the worksheet is put in as 4 pages. The first 2 are questions. The last 2 are the answers to those. So you can always check your work and judge yourself. Okay? Never a bad call. First one. Isosceles right triangle. Okay, isosceles means 2 equal sides. We remember that. Okay, now if it's an isosceles right triangle, we know the legs have to be equal to each other. Okay, and they are. The legs are always the same length. Okay, now in a 45, 45, 90, here's where the special relationship comes in. You don't have to use the Pythagorean theorem here. We know that the length of the hypotenuse is whatever the leg is multiplied by radical 2. Okay? So if this is 10, we know that's 10, and this is 10 radical 2. When we talked about Pythagorean theorem, we had to have 2 sides. On these special triangles, we only need 1 because we know the ratios. Okay? It works backwards as well. If this is 15 radical 2, okay, 15 radical 2, this is 15, this is 15. Now, the toughest this is going to get is if this is representing a whole number. So, if this is 12, okay, x radical 2 is 12. You've got to take the x out of it, which means we divide by radical 2, which is why we took the time at the beginning of the chapter to go over radicals. Okay? Dividing 12 by radical 2 gives you 12 over radical 2. Remember how we rationalize it. Multiply by radical 2. Radical 2. Simplify. You'll get 6 radical 2. Most of you will figure out the shortcut to that very quickly. Okay? That's the toughest part of this. The next one is a 30, 60, 90. And on this we have to make sure we realize what opposite means. Okay? The smallest angle, the 30-degree angle, and the shortest side are opposite each other. Okay? Little bitty angle only opens a little way across. Okay? So, smallest angle, opposite shortest leg. The shortest leg is opposite the 30-degree angle. Okay? We just On this one I use y. I used x up there, I use y down here to differentiate. Okay? Now, you can't let that freak you out when you get to a problem and it's asking you to find x and y. Don't worry about it. You want to use a and b here? Use a and b. I don't care. Okay? And you shouldn't either. Just know the relationship. They're not just friends. It's important. Okay? So, the next one, the longer of the legs is opposite the 60-degree angle. Okay? Bigger angle, bigger opposite side. No big deal. Okay? It is found by taking the length of the shorter leg and multiplying by radical 3. Okay? And finally, the hypotenuse, which is always opposite the right angle, okay, biggest angle, longest side, is 2 times the shortest leg. So if you can find the shortest leg, you're in business. Okay? Here's your trick to remembering this. If I have 2 equal sides, I use radical 2. If I have 3 different sides, this is radical 3. This is what we're going to be dealing with. Example. If this is 5, this is 5 radical 3, this is 10. 2 times 5 is 10. Okay? If you are given the hypotenuse, if this is 20, 20 divided by 2 is 10. This becomes 10 radical 3. Okay? Once again, the toughest one you're going to encounter is if the y radical 3 is given to you as a whole number. If this is 18, okay, that means y radical 3 equals 18. Divide 18 by radical 3, rationalize it. We know how to do that. Okay, so 18 radical 3 over 3. You divide, you get 6 radical 3. Okay, so 6 radical 3. 2 times 6 radical 3 is 12 radical 3. That's all we're dealing with here. Okay? Until you are comfortable with this, it's probably not a bad idea to put those in there. Okay? So, let's go to our examples. Okay. On these, we are going to find the length or value of each variable. We've got a bunch of questions today, and you're going to have a bunch on your assignment, but there's no work involved. Okay, so I don't feel bad. Okay, so let's start. Here we go. I've got a 45, 45, 90. I've got a leg is 14. 14 times radical 2 okay, remember what I said. Don't freak out because they're using x and y's here. Just because I used them on the examples. Maybe when I come back and take the pictures, I'll change it to A and B, just because some of you literally, you look for the smallest reason to lose your minds. Don't do that. Minds are important. Okay? I didn't say mimes. I said minds. Okay? Let's move to here. I've got a 45, 45, 90. Ooh, they gave you a 45 length. Okay? Length of sides and angles, different animals. Remember that. Okay, so this is this length times radical 2. Okay, so x is going to be okay. Remember, we've got to multiply top and bottom by radical 2, which will give me you can leave it like that, or you can divide it in half and make it 22.5 radical 2. It's up to you. Both are correct answers. Okay? 45, 45, 90. Leg is given to you. 22 times radical 2 is your answer. That's it. Okay? Seriously, I wasn't lying to you about this being easy. Okay? We're still practicing on this. Keep practicing. It's important. Okay? It's a good skill. Okay. We need the hypotenuse. 45, 45, 90. I've got the leg. 88 times radical 2. Lying to you. Okay? Let's come up here. Ooh, we have a whole number for the hypotenuse. We have to divide it, okay, to go back to the leg. So 210 over radical 2. Multiply top and bottom by radical 2. Gives you 210 radical 2 over 2. Simplify. So 105 radical 2. Done. Move on. Okay? Okay. I got a leg with a radical in it. It's going to change anything? No. No, it's not. We're going to say, okay, leg, hypotenuse. This hypotenuse equals the leg times radical 2. So the hypotenuse equals so 5 radical 2 times radical 2. Radical 2 times radical 2 is just 2. Okay, 5 times 2 is 10. That's it. That's it. That's really, really it. Okay? And some of you are still going to say, I don't understand. Because you're not practicing. You expect to get it all within 30 seconds. Life isn't that way. Okay? Learn to work through a process. It's important. Okay. Now we go to a 30, 60, 90. We've been given the short side. Okay? So that times radical 3 and the x. 2 times 9. You're done. Okay? 30, 60, 90. Okay, the hypotenuse has a radical 3 in it. Okay? Divide 4 radical 3 in half to get to the short side. Four radical 3 divided by 2 is 2 radical 3. This, across from the 60, is going to be this times radical 3. Two radical 3 times radical 3 is just 3. 2 times 3 is 6. That's it. We're moving on. Got 2 more here. Okay, right there. Same thing, both 30, 60, 90s. Sorry, bringing over. Okay, so 30, 60, 90. Okay. On this one, we are given the shorter leg. That just means the 60 is there, so the x is across from it. So the hypotenuse is there. 2 times 20 is 40. Okay? Here we go again. That's 30, that's 60, that's 90. We are given the hypotenuse. Half of 98 is the short leg, which is 49. So that short leg is 49. Then we come to the one across from the 60. So we take that and multiply it by radical 3. Okay? Okay. Those are problems where you're just given the triangles. Now, what if we have to create our own triangles? We can do it. We have the technology. Okay, here we go. Determine the length of the leg of a 45, 45, 90 triangle when the hypotenuse is 38. Okay. 45, 45, 90. Hypotenuse. That is one of these multiplied by radical 2. Divide 38 by radical 2. Okay? We take that, we rationalize. Okay, so 19 radical 2 is the length of a leg. Okay? Find the length of the hypotenuse of a 45, 45, 90 if the leg is 77 centimeters. Same triangle again, 45, 45, 90. Sketch it out if it helps. Okay, 77 times radical 2. That's all. Okay? Now this one we have to look at a little bit, okay? An equilateral triangle has an altitude length of 33 feet. We're going to start by drawing that. Now, why is this important? Remember, an equilateral triangle is also equiangular. Okay, so 180 divided by 3, 60, 60, and 60. Okay, so we have 30, 60, 90 triangles. Because when the altitude is drawn in, it bisects that angle. Okay, so now we look at this, and you'll notice the altitude is across from the 60-degree angle. Yes, we have to divide 33 by radical 3. Okay. Okay, and that's what this is right here. Also this. Which means together, okay? So that's what we're going to do. That's that part. Okay, this is 66 over radical 3. So we've done our job here. Okay, this has to be rationalized. Divide. And that's your answer. Okay? Yes, there'll be pictures in a bit. Now, our last one is purely a word problem. Okay? One of the displays at a botanical garden, okay, and if you ever get to go chance to the botanical gardens in Arcadia, do so. It's beautiful. Okay? Is planted in the shape of a square. The square measures 6 yards on each side. Visitors can view the display from a diagonal pathway through the garden. How long is the pathway? Okay, I'm going to sketch the square. Okay. The diagonal pathway, we'll just look at that, okay, is there. The sides of the square are 6. Remember, when you draw in a diagonal to a square, you bisect the angle. 90 cut in half I have a 45, 45, 90. Okay, this diagonal is just going to be 6 radical 2 is it. And we can leave our answers just like this. Okay? Very good. Trust me, work through it. It becomes easier as it becomes familiar. Okay? Got to work through it. Okay? Go to work.